Alright, this is lesson 80, solving quadratics, choosing which method is best. Okay, so I've taught you all these different methods, and the directions on all of them were solve, which means find the answer to the letter. Solve means find the answer to the letter. What does solve mean?
Find the answer to the letter.
Okay, good. So whenever we see quadratics, it's x squared. So x squared, we know it's quadratic, right, from the beginning of the year. So no method is right or wrong. You could use any method on any problem. You could graph on all of them. You could use square roots. You could do complete the square. You could even do Xbox if you're really good at it, okay? You could do any method on any problem. But sometimes one method is better than the other because it's faster, right? What's the best method? The fastest method to get you the right answer. Does that make sense?
Yes.
So, because in life, you could do a lot of ways, and or you could get to a goal in a lot of ways. Let's say, for example, you live 2 blocks down the street. Okay. What's the fastest way to get to school? Car. But what if there's a ton of traffic? Is the car the fastest way?
No.
Bike? But what if there's like a ton of people and there's traffic?
Walk.
Walk. Tank. No, just play. Okay. Everyone know. Air balloon. Jet. Well, jet. We don't have a jet. That's outside. What?
Cruise ship.
A cruise ship. Definitely not appropriate, right? So there's a lot of ways to get to school, but sometimes the best way might be just to walk because there's a lot of cars and then there's a lot of people. You can't really take your bike, okay? Is any method wrong? Let's say the streets are empty and there are no cars, no people, and could you still take your car to school or tell your parents to take you to school with your car?
Yeah.
Yeah, could you tell your parent, or can you ride your bike to school?
Yeah.
Yeah. Can you still walk to school? Ride your skateboard to school? Yeah. Which way is the right way? All of them. It's just whatever you prefer. But sometimes there's the easiest way, which sometimes is the car, sometimes it's taking a bike, sometimes it's walking. Or even the bus, right? So, that's what we're talking about today. That's the concept. There's a lot of ways to get to the answer. Which way is the best, okay? These are the steps. These are all the ways I've taught you. I've taught you how to find the GCF, how to Xbox, how to find difference of squares, take a square root, complete the square, quadratic formula with a discriminant, and then graph, remember? So look at all the stuff you've learned. It's a lot. Done a lot, but you should all be able to do that right now, okay? So watch me do numbers 1 and 2. Okay, number 1. First thing I want to do, it says solve. It says k squared, so I know it's quadratic. So the first thing I want to do is ask myself, what method should I use? I know that A is here, B is here, but C, there's some here and there's also some here. So I want to connect these two. So I'm going to subtract 4 on both sides. Okay. Oh, it's equal to 0, sorry. Not 4. So there's A, B, and C, right? So on this first one, I could do GCF technically, but I can't, the easiest way I would think is to do Xbox. Because I see that there's an A, B, and C, so I could go 1 and 1 for A. A times C is 0, B is 1. What times what is going to equal to 0 but equals to 1? How about 1 and 0? Right? 1 times 0 is 0. 1 plus 0 is 1. Right? Box these up. Oh, that first box. Not very good. Use my pen. Okay, so this is going to be k plus 1 times k plus 0 is all equal to 0. So k plus 1 is equal to 0. And k plus 0 is equal to 0. I know if I subtract 1 on both sides here, this is going to be equal to k is equal to negative 1. And the second one, k plus 0 is just k, so k is just equal to 0. Nothing else to do, right? Those are my two answers. Right? That was the fastest way to do that. Could I have graphed it? Yeah, but graphing would have taken a while. Could I have done quadratic formula? I think that would have been longer, right? It would have, right? So that's number 1. So I used Xbox in number 1. Okay. Number 2. Let's look at number 2. Number 2, I'm noticing, okay, A is 81, B, there's no B, and then the C's are apart. So, when I see that there's no B, first thing I'm going to do is subtract 26 on both sides. When I do that, I get 81 n squared minus 25 is equal to 0. Oh, look at that. There's no B. So there's 2 things I should think about. Difference of squares or take a square root. Let's check difference of squares first. Is this a perfect square? Is 81 a perfect square?
Yes.
N squared is a perfect square, of course. 25 a perfect square? Yeah, so these are both perfect squares. Is there minus n in the middle? Yep. So now we're going to use difference of squares. Square root of 81 n squared is 9n. A square root of 25 is 5. Put a plus sign and a minus sign. And now we're going to solve each of these. 9n plus 5 is equal to 0. And 9n minus 5 is equal to 0. Therefore, 9n is equal to negative 5. And n is equal to negative 5/9. And we're going to add 5 here on each side. So 9n is equal to 5, or n is equal to 5/9 as well. Alright? And that's how you do number 2. Now, could I have done an Xbox on this? Yeah. But what's 81 times 25? That's a huge number, right? Or couldn't I have done quadratic formula? Yep. But what's negative 4 AC? 4 times 81 is 324 times 25. That's a huge number all of a sudden. We're dealing with like 1,500. Too big of a problem. So better that we go use these other methods. Does that make sense, everyone? Okay. So we're not going. You could use any method to get the right answer, but the question is which one to use. That's when you have. This is the harder part. You have to pick for yourself. Okay. So what I'd like you to do is turn to your neighbor, tell them why I picked the method I did. Okay. So one, tell the twos why. Tell them why did I pick Xbox on number 1. On number 2, tell them why did I pick. Twos will talk to the ones about why did I pick difference of squares. Okay. Ready, set, go. Everyone's talking. Why? Number 3. Okay, number 3. Y is equal to negative x minus 2 squared minus 2. Okay. Is this in standard form? Yes or no?
Yes. Oh.
No, it's not. What form is it in? Vertex form, okay. When do we ever use vertex form? What? Graphing. So, should we convert this to quadratic or standard form, or should we try to graph it?
No.
Let's graph it because it's already there. We could graph it pretty easily, actually. No, don't graph it. No. Okay, so. Okay, so since we know h and k are, negative 2 or 2, negative 2, we know that those are going to be our center points. So 2, negative 2, let's pick a couple of bigger numbers in 2, 3 and 4. 2 smaller ones are 1 and 0. If I put 0 in here, just like yesterday, the 0 minus 2 squared is, or 0 minus 2 is negative 2, negative 2 squared is 4. 4 times the negative sign is negative 4. Negative 4 minus 2 is negative 6. Okay? 1. 1 minus 2 is?
Negative 1.
Good. Negative 1 squared is?
1.
1 times the negative sign is?
Negative 1.
Negative 1 minus 2 is? Negative 3. Okay. What do you think the answer is here and here?
3 and 6.
What? Negative 3 and negative 6, not 3 and 6. That would be wrong. Okay. Now let's think about this. Which way is it going to open, up or down? Down, okay. So let's just draw a rough graph. If our vertex is over 2 and down 2, if this is our vertex, it opens down. So this is a messy graph. That's not what you're supposed to do, by the way. But let's think about the concept here. If it's opening down, where are the roots? Where does it cross the x-axis? Where are the solutions? Is it ever going to cross?
No.
No. So do I have to draw a pretty graph?
Yeah.
No. So what's the solution? No what? No what? No real solutions. Thank you. Did y'all get that? Now, what if it did cross the graph? Would we have to draw it pretty then? Yeah. So remember, use common sense. Why would I take time to draw it pretty when I know that I could just save time? Does that make sense? Now turn to your neighbor and tell them why did we graph instead of doing anything else, and tell them why we didn't do a... So 1's tell the 2's why did we graph, and then 2's tell the 1's why did we do a ugly graph instead of a really nice one. Okay? Go. Again, why do we graph? Why? Everyone, why do we graph? Because it's already in vertex form. It'd take more work to go the other way. Why did I not graph it like perfectly at the ends? Right? We predicted that none of the points would cross the graph, right? Because it's supposed to open down. So did we even need to make a table? Not really. Did y'all get that? What should we have even made a table for this one? No, because we could have just got the vertex and be like, oh, it's going to open down. It's going to be no solution, right? Don't you want to save time on a test? Right? Or homework? Or do you like doing homework?
I don't like it.
You all love doing homework. You all love... You can't wait till you get your hands on your paper at night. You're like, yes, I love Mr. Rink's class so much. Can't wait to do homework. Because I want to be like him one day. Okay, number 4. Shh. Really? Okay. Okay, number 4. Okay, number 4, let's look at this one. A is 1, B is 4, C is 84. Okay, so let's try to put all the C's together. Let's see what we could do here. K squared plus 4K plus 87 is equal to 0. Is that right? Yeah, that's right. Uh-oh. Okay, let's see. Can we do Xbox here?
Yeah, no. Yeah.
We could. Now, let's predict. Just, you should think about this in your head. But A is 1 times, or A times C is 87 and B is 4. What times what does it get multiplied to be 87 but adds up to 4? Nothing, right? So we could do that in our head that we can't do Xbox. So can we take a square root? Is there a B? No, we can't. There's no GCF here.
Oh, no, just kidding.
Can we complete the square?
No.
No. Yeah, we can complete the square. You want to try to complete the square? I bet you we could do this really quickly. Faster than quadratic formula. Let's think about it. Let me lead you through it. Ready? Complete the square. First step, complete the square. What do we need to move again? All the C's over, so we need to move all these back over to the opposite side. Believe me, you're going to like this better than quadratic formula. Because think about it. What's quadratic formula? Remember B squared minus 4AC? What's 4 times A? 4 times 1 is?
4.
4 times negative 87 is? Never mind, right? Do we want to deal with that? Negative 3 something, yeah. So do we even want to do 4AC? Would we want to do that? No. So let's do quadratic, or complete the square. Ready? So subtract 87 on both sides. K squared plus 4K is equal to negative 87. Okay? Is A equal to 1? Yes or no? Yes. Okay, what's half of B?
2.
Okay, so half of B is 2. 2 squared is 4. So we're adding 4 here and 4 here. So the left side becomes K plus 2 squared. Right side becomes, what's negative 87 plus 4? What's negative 87 plus 4? Negative 83. Okay. Next step, what would you do? How would I get rid of the squared here? Square root. Good. This cancels out. Is anyone having an aha moment right now? Okay, what's the square root of a negative 83? Come on, kids. What's the square root of a negative? Raise your hand if you just had an aha moment. Ah, what's the square root of a negative? There is none. So what's my answer already?
0. Oh, 83. Negative 83.
Hoo. Maybe you should take algebra 1 again next year.
I'm thinking of
No, really, what is the square root of a negative number again? No square root of a negative, so it's no real solution, right? Sorry, that was a little rough. You should all take geometry next year. But some of you might need to take it again. No real solutions, right? Wasn't that easier than the quadratic formula? Yeah. So is complete the square all that bad? No, sometimes it's like, bam, I could get the answer. Because, right, 4 times 87, that's even a little too much for me to deal with sometimes.
That's why I use a calculator.
Yeah, but sometimes on the test you can't use a calculator.
Oh.
Oh.
On the side of your paper. Oh.
Are you laughing at your own joke right now?
Who laughs at their own jokes?
I do, all the time.
Yes,
Ha ha ha! That's fun.
Same.
Okay. Turn your neighbor, explain why we couldn't do Xbox, and explain why we didn't want to choose quadratic formula. Ready, set, go. This one again, we did complete the square. Right, so put that on the side. Okay, number 5. Talk to your neighbor, tell him what you would do on this one. What would you do, everyone? Y graph?
Because it's a vertex.
Vertex, vertex what? Vertex form, thank you. Okay, good. So what is our H and K here?
H is negative 4 and K is
Good. So let's, before I even make a table, let's just see if we're going to have solutions. Just think of it. Rough graph. Negative 4, negative 1 is about here. Which way is it going to open, up or down?
Down. Or no.
What do you think? What's A? Is it going to open up or down? Up, right? So do you think we're going to have solutions? Yeah, we probably will, right? So we need to do this neatly. So here we go. We need to not graph sloppy. We have to do this correctly. So make an XY table. This is from yesterday now. We got negative 4, negative 1. What are two smaller numbers than negative 4?
2.
No, negative 5, negative 6. What are two bigger numbers than negative 4? Negative 3, negative 2. Okay. Are you understanding the negatives, Rebecca?
Yeah, no.
Okay, good. I just want to make sure. Okay, so let's do this together. What's negative 6 plus 4? Negative 2 squared is? 4 times 2 is? Minus 1? 7. Good. Okay. Where else should I put a 7? Good. By the negative 2. Excellent. Good. Now let's do the negative 5. What's negative 5 plus 4? Negative 1 squared is? 1 times 2 is? 2 minus 1 is?
1.
1. Good. going to put a 1 here. Okay. So now we're kind of having a bit of an issue, right? So do we have any zeros? No. So let's graph this, okay? So you would have to write this neatly, okay? I'm going to put up a graph right now. Okay, if this is my graph, those are the numbers, right? You go negative 6, 7, so I go over negative 6. That's a point, right? 1, 2, 3, 4, 5, 6. Oh, I missed it by 1. Is that right? Then the next one is negative 5, 1. 1, 2, 3, 4, 5, 1. Next one is negative 4, negative 1. Negative 2, 7. 1, 2, 3, 4. Okay, so what do you notice about this one? Is it crossing perfectly here?
Mm-hmm.
Yes or no?
Yeah.
No, it's not. Is it crossing the x-axis at a perfect point? No. So then we would just we would say, we would have to estimate it. So what is this point? Negative 1, 2, 3, and it'd be negative 3.5, right? Would you all agree? So x is equal to negative 3.5. And what's the other one? Negative 1, 2, 3, 4, and
Half.
good. So is graphing always perfect?
No.
No, it's not. Okay, so on this example, I wanted to show you that graphing is not always perfect, okay? Last one, number 6. Ready? No, that's not the last one. I just play. Oh, sorry. Nope. Okay, number 6. Last one. I'm going to hide number 5. Okay. What's A?
5,
B?
20,
Negative 20.
or negative 20.
C?
7.
Okay, good. But are my C's together?
No.
No, so that's really not C. So let's add 5 to both sides. So we got 5x squared minus 20x plus, good, plus 62. Now, it's all equal to 0. Should I do Xbox here? Yes or no? Can I do Xbox?
Yeah.
Yeah, I might be able to, yeah, but those are pretty big numbers. What about can we do difference of squares? Is this a difference of squares problem? No. What about take a square root? No. Okay, what about complete the square? Do I want to try to complete the square on this?
Mm-hmm.
No, because if I subtract 62 and I have to divide by 5, what's 62 divided by 5? A number, right? With a decimal, right? Or a fraction. So you haven't learned how to deal with that. In Algebra 2 you will, but right now no. How about quadratic formula? Yeah, we could do quadratic formula. But before we do the quadratic formula, always, what should we do first? Check the discriminant, okay? So let's do the discriminant first to make sure if there are any solutions, okay? So let's do b squared minus 4ac. Okay, so we're going to plug it in. So we got negative 20 squared minus 4 times a times c. We're doing the discriminant. We want to check to see how many solutions there are. What if it's no solution? Would we have to do the whole quadratic formula? Nope. Okay, so negative 20 squared is 400. Okay, what's negative 4 times 5?
20.
Negative 20 times 62 is? Well, let's plug it in. Do a side problem. No. What's negative 20 times positive 62? Negative 1,240. Okay, good. So what's 400 minus 1,240? What's 400 minus 1,240?
840.
Nope.
Negative 840.
Good, negative 840. Okay, good. That's our discriminant. From what you learned about discriminant, shall we move on using the quadratic formula? How many solutions will there be? It's negative, so one solution?
Oh, wait.
No solution.
No what solutions? No real solutions. So should I do the quadratic formula here? No, we're done. See how easy that is? So on each problem, you won't be able to know. That's your answer, no real solutions, right? So yay, that was easy at the end. Sometime, what if it was real solutions, then you would have to do the quadratic formula. Okay? Did you all get that? Okay, so sometimes there's going to be a variety of different ways to do the same thing. You just have to know what questions to ask. You want to do Xbox if you could do the Xbox easily. You want to do difference of squares or complete the square if there's no b. You want to do complete the square when you can complete the square but you can't do Xbox. Let's say you can't do Xbox, then try and complete the square if it's easy enough. You want to do quadratic formula if complete the square you can't do it. And you can't Xbox. But before doing quadratic formula, check for the discriminant first. Does that make sense? And you want to graph, when do you really want to graph? When it's in which form? Vertex form. Did you all get that? So on a test, I'm not going to tell you how to do it. I'm not going to tell you what form to use. I'm just going to say, or what method. You're going to have to figure that out. Okay, but this is the list. You already know how to do all of these forms. So check your forms, okay? And check your work before you start. That concludes this lesson. So what I'd like you to do right now is turn your neighbor, explain, and discuss these 4 questions. Ready, set, go.